Tom Mewald. I'm a conservation planner with the U.S. Fish and Wildlife Service. I'm out of the Portland Regional Office. And what we'll do today is we're going to talk about our process for selecting focal species for connectivity analyses in coastal Washington. And so I want to go through the agenda here really quick. First of all, I'll give a brief overview of the project and the broader landscape conservation design effort that we have. And then I'll hand it over to Peter Singleton from the U.S. Forest Service to talk about all the great work that the Washington Habitat Connectivity Working Group has been doing over the past 5 to 10 years. Then I'll hand it over to James Bagley with Peter as well, talking about the modeling process and the end products and how these will be used. And then finally, I'll hand it over to Kelly McAllister and Jeff Azerrad, and they'll walk through the process. So really what we want to do today is propose a process for selecting focal species across the coastal ecoregion of Washington and get your input on this, and also invite you to score and provide input on important factors to consider when choosing focal species for wildlife habitat connectivity analysis. So we really want to make this as collaborative as possible and really get people's input, because I think that's what's going to make this project successful over the long term. So without further ado, I'm going to dig into the place that we're talking about. So the boundary that you see here was determined by the Washington Habitat Connectivity Working Group quite a while ago. I'll let Peter talk about when that boundary was developed, but it represents that coastal ecoregion west of the Cascades and into the coastal regions, including the Olympic Mountains. So we developed a goal statement for the connectivity analysis, and that is to use science-based methods to identify connected habitat networks and prioritize areas for conserving and or restoring conditions that promote desirable wildlife movements for the broadest possible range of native species. A few considerations as we do this is that this will be based upon a GIS analysis using models in collaboration with stakeholders in the region. We're going to focus on current landscape conditions, including current vegetation, land use, and land ownership. And we really want to think about connectivity networks within the context of working lands in the region. And we know that working lands can play an important part in habitat connectivity, so that is, we want to make that important consideration. We want to also optimize locations for providing connectivity across barriers like highways. So I'll give a very brief introduction to the broader project, and I do want to also call out that the broader project includes the coastal ecoregion of Oregon and Washington. I want to point out that Oregon is doing a habitat connectivity assessment, and they just selected species as well. So Rachel Wheat is the coordinator for that effort, and there's the Oregon Habitat Connectivity Consortium, along with researchers that will be developing maps and models in that region as well. We're going to use a separate but parallel process up in coastal Washington, and the goal is to have those two geographies very much aligned in terms of methods, approaches, focal species, and things like that. So when we talk about landscape conservation, we want to talk about, we're thinking regionally and acting locally across ecosystems, across the landscape, and across geographic scale, so that you will be talking a lot about that coastal Washington, and knowing that there's a whole lot of landowners in that region. If we want to talk about habitat connectivity, we have to include the people who use and own and manage the landscape as well. And what we really want to get down to are things that we can do on the ground that add up to broader spatial patterns at the landscape scale. And that's a big part of the broader landscape conservation design project. And we're, as part of that process, which we're partnering with the Habitat Connectivity Working Group on developing strategies and approaches for wildlands, farmlands, rangelands, and tribal areas as well as part of this whole look at the broader landscape. And so with that, that's kind of a broad overview of kind of the landscape conservation goals that we have in this region and what this connectivity assessment is about. With that, I'll hand it over to Peter Singleton to talk about the history of connectivity in the region. First, I'll ask if there's any troubles getting on the webinar or if anybody's having any other audio-visual issues.
It's working good.
Okay, good. I will display full screen, and Peter, go ahead when you're ready.
Great. Do you want to put me on the first slide there, or?
Yeah, let's start there.
Okay.
Yeah,
so,
thanks.
No worries. not that the title is really too important for this group. I think you guys are probably, if you're on the phone here, you're probably pretty familiar with the Washington Wildlife Habitat Connectivity Working Group. But go ahead to the next slide there, Tom. You know, the Wildlife Habitat Connectivity Working Group now has been going on for 10 or 20 years, depending on how you measure the starting point. And the mission of the group has been to promote the long-term viability of wildlife populations in Washington State through a collaborative approach that identifies opportunities and priorities to conserve connectivity. You know, I think the key terms here in this mission statement that we came up with 10 years ago is this idea of science-based and collaborative. You know, there are a whole bunch of people that have been involved over the years, and people have come from a variety of backgrounds to engage in this work. Go ahead to the next slide. You know, the backgrounds of folks have included state and federal regulatory agencies, tribal groups, academic institutions, Woodland Park Zoo should be on that list now, and nonprofit groups that are in position to advocate for implementation. It's really served as a very effective group in terms of providing lots of different backgrounds, from the science and modeler types to the communication and advocacy types that allow us to move the work forward. Go ahead to the next. Okay, so this sort of collaborative open structure is sometimes, you know, a little like herding cats to move forward, and the form of the working group has really changed over time as resources and people sort of ebb and flow. But the idea behind the working group was to sort of have this large, inclusive, full group that kind of encompasses anybody that wants to show up. You know, the sense is to try to be as inclusive as possible. You know, and when you've got that kind of model, obviously not everybody is going to be able to engage all the time, and that responsibility of providing a core group with the momentum to have a sense of progress and forward motion really has fallen on the core team that includes folks from Department of Fish and Wildlife, Department of Transportation, and other groups, including Conservation Northwest and various independent researchers. So, you know, that kind of forms the nexus, but also really important to accomplishing this work has been sort of the incorporation of these different subgroups, people that are involved in the modeling, but also people that are involved in writing and editing and implementation and communication. So I think often we really focus on the science side of this stuff, and the focal species selection, the modeling, the mapping, the GIS, the climate change analysis, but equally important are the communication and implementation application sides of this that folks from a variety of backgrounds can contribute to. So, so I think, you know, the big point here is I want to give a shout out to all the folks that have been involved in this and all the opportunities that there are to be involved. You know, you don't need to be pushing the buttons on the linkage mapping software in order to provide a substantial contribution to this. So go ahead to the next slide. One of the fundamental ideas behind the way the working group has tried to approach this is sort of a sense of you know, hierarchical scale in assessment and implementation. Okay, we started 10 years ago with a statewide analysis, and right off the bat, our sense was that that was not going to be a final implementable product. The idea with the statewide analysis is it would provide a broad-scale context that we could then drill down to and ask more specific questions at eco-regional scales that could then lead to actual actionable implementation and validation activities at very local scales. So as we go through this, I think you'll sort of see me coming back to this idea of hierarchical assessment and implementation time and again, and I think that's something that's real important to keep in mind as we move down into Southwest Washington. So go ahead to the next. So again, it depends on when you want to start the clock on the Habitat Connectivity Working Group as to how long we've been around. My personal history on this stuff goes back 20 years with working on the I-90 linkage assessment and development of cost-weighted distance connectivity modeling approaches for the Snoqualmie Pass work that we then scaled up to a regional scale. I think having that stuff on board and seeing the utility of the I-90 work sort of brought together the broader interagency group that created the Habitat Connectivity Working Group in 2007. I think one of the important lessons for me with the I-90 stuff was that there was no project planned along I-90 at Snoqualmie Pass at the time we started that linkage assessment work. A few years later, there were resources that became available and interest on the part of WSDOT to do highway reconstruction in that area, and having that linkage assessment foundational information in place when the planning started for the highway reconstruction really provided a strong foundation for getting habitat connectivity into the purpose and need statement for the EIS for that project. And, for me, it was a lesson in the importance of being ahead of the ball. Often we don't do this kind of assessment work until there's a project that's already going on and we're sort of in a reactive mode and we need to figure out how mitigation should be planned or how things can be done to improve a situation. But actually having that assessment work done beforehand can help inform the development of the project and really put things in a much stronger footing for creating good projects. So the first step with the Habitat Connectivity Working Group was the statewide assessment that we did from about 2007 to 2010. That grabbed that big, broader red square that went up into British Columbia and adjacent portions of Oregon and Idaho to really look at the connectivity patterns across the state of Washington. Once we did that, there were some add-ons with some climate connectivity assessment that were value-added products that we tagged onto that. But we quickly realized that, as we expected, there were important questions at finer scales that the statewide analysis didn't allow us to get into. So from the statewide, we stepped down to the Columbia Plateau. The Columbia Plateau was a real gem of an opportunity where there was a combination of need, opportunity, interest, and brain power and support that provided the opportunity to really refine our methods and the questions that we had with the statewide analysis. And we also, we learned a lot in the statewide analysis, and we got a chance to do it better in the Columbia Plateau. After the Columbia Plateau, we stepped up to the transboundary Okanagan-Kettle analysis area. That was a little more streamlined process where we were more focused on looking at existing products and learning from those. And now we're getting down into Southwest Washington. So go ahead and go to the next slide. So one of the things we got out of the statewide analysis was that, you know, there wasn't one network for everything. Okay, we looked at 16 different focal species with the statewide analysis, and we did a landscape integrity based modeling approach, and we did a climate gradient corridor analysis. I would say that, you know, all these reports that I'm going to be talking about here are available on the waconnected.org site. I have that at the end there. If you want to dig into any of this stuff with more detail, please go to those reports. But as you can see from these three synthesis maps where we sort of did a spatial analysis of overlap of the networks for each of the 16 focal species and landscape integrity, you know, we found that you know, stuff that was good for the montane species like lynx and wolverine and mountain goats didn't work for the shrub steppe species. And then there were these generalist or oddball species that had more localized distributions or had real broad habitat associations that were captured in this kind of generalist network. You know, I think these were very informative products, and it gave us a starting point to understand what the patterns were that we were interested in. But there were real challenges associated with developing a single connectivity model for each species that was supposed to work across the entire state. For example, with black bear, you know, to get a black bear model that worked in the Cascades in northeast Washington, it didn't work in southwest Washington because the landscapes are really different and the pressures in those areas are really unique. So let's go on to the next slide. Okay, so from the statewide, we stepped to the Columbia Plateau. You know, in the statewide, we really had two assessment product reports with the statewide assessment and the climate connectivity stuff. With the Columbia Plateau, we came up with 5 reports. Like I said, you know, we had additional resources, we had additional manpower, we had a lot of interest in this landscape, which was severely fragmented by agricultural development and had some serious endangered species issues. We also had learned a lot in the statewide process and developed some new tools, and were able to dig into things like network centrality, pinch points, barriers, and we did a lot more with sort of integrating different kinds of analyses like least cost corridor and circuit-based assessments. And so, you know, I think that, you know, the Columbia Plateau assessment still stands as a real state-of-the-art kind of project in terms of digging into these things. And you know, as I'll mention on down the line, you know, we've got tools that we developed in this process now that streamline this and provide the opportunity to do this at much less cost than we did with the Columbia Plateau. So go to the next slide. So with the Okanagan-Kettle transboundary area in BC and northern Washington, we were faced with a different kind of situation where there were different sorts of questions regarding the very rapidly developing urban and suburban landscape in southern British Columbia through the Okanagan Valley, in contrast with the relatively rural and low population density landscapes in Okanagan County in Washington. Here our approach, instead of rerunning the focal species and landscape integrity kind of modeling that we did for statewide and Columbia Plateau, with this we dug more into the existing products that we already had and tried to articulate priorities for mitigation or connectivity enhancement in those areas that are highlighted in the darker purple colors in this summary map. So I think, you know, the take-home message here is that one size doesn't fit all in this process. You know, there were different kinds of questions, different kinds of resources, different kinds of opportunities that that made it worthwhile to go with a different kind of approach. Okay. On to the next slide. So this information has been applied in a variety of ways. Here I sort of, you know, chose to highlight 3 different examples, but I think there are lots of others that are out there that people can draw on too. You know, as I mentioned before, getting ahead of the ball with having an assessment of wildlife movement patterns and some hypotheses that we could really articulate and get people off off the ground with for further work during the development of the connectivity mitigation plan for the I-90 Snoqualmie Pass really put us ahead of the curve, and 20 years later after we started that work has led to the implementation of a state-of-the-art mitigation plan that includes not only highway overpasses, but I believe the count was something like 96 separate mitigation features that are largely enhancements of drainage or other kinds of things that would have been included in the highway but have been modified to really address wildlife movement and provide ecological connectivity in addition to the other objectives for engineering objectives for those structures. The Columbia Plateau work, as I mentioned, stepped into a landscape where there was a real need for understanding the effects of land use, including agriculture, on endangered species recovery. Sage grouse have been an important topic in this area, and so including people that were involved in sage grouse recovery in the connectivity assessment provided the opportunity for folks to really understand what was going on with the connectivity work and incorporate that effectively into species recovery plans. So I think that was a real hit. The transboundary work in the Okanagan and along U.S. Highway 97 in the United States really highlighted the importance of the landscape south of the border for maintaining east-west connectivity. When I came into this work in Washington, I came from Montana, where Canada was the great source population to the north, and I sort of figured that once you get over the border into Canada, things are well connected and it's a great mountainous landscape, and that's not necessarily the case. The Okanagan Valley in Canada is an extremely rapidly urbanizing landscape that provides a variety of challenges and highlighted the importance of the Okanagan Valley on the Washington side of the border for potential connectivity issues, and has moved forward with support from the National Fish and Wildlife Federation and collaborative initiatives with Conservation Northwest and the Department of Transportation to look at getting ahead of the ball on connectivity mitigation and work in that Okanagan Valley landscape. So I think these are all really good examples of places where we've been able to implement this stuff. I really want to give a shout out to the tools that we've developed in this working group. The linkage mapper software that we developed through the process of the statewide and Columbia Basin projects has really streamlined the implementation of the cost-weighted distance, least cost corridor kind of suite of tools. The gnarly landscape utilities, which used to be called the Habitat Concentration Area Toolkit, meshes in with linkage mapper to really streamline these analyses, and now they're used globally. They've been used in northern India for assessing tiger connectivity. They've been used on the Vietnam-Laos border for looking at multi-species kinds of conservation issues in national parks. And the integration of these tools with circuitscapes and omniscapes, I don't think the Washington Habitat Connectivity Working Group can necessarily take credit for circuitscapes and omniscapes, but I think there's a real shout out to Brad McCrae here, who was a very central figure in the work that we did up to his death in 2017. And his work with circuitscapes has been a real paradigm shifter for anything that involves any kind of analysis that involves looking at patterns of flow across landscapes. And his circuitscapes software has been used in everything from wildlife to epidemiological research now. And so I think for the suite of stuff that we've developed in collaboration with Brad and with Andrew Shirk and with others that have been involved in the modeling work has really brought us forward. I'd also give a shout out to the stuff that Andrew's doing now for integrating some of the linkage mapper functionality into Google Earth Engine and getting us into sort of this cloud-based analysis work where things are really able to be updated on the fly, is sort of moving into the next generation of this stuff. So just one last shout out to the waconnected.org website. So leave that up there, Tom, so that people can get that website. I think that's a real critical one if you're interested in this stuff. All of the assessment reports that we've talked about so far here are posted on the website, and there are linkages to the data basin repository where all the spatial GIS layers from all these analyses are available. So I think one of the key things with the connectivity working group is to try to be as transparent as possible and try to make these products as accessible as possible to folks. And the main portal for that is this waconnected.org website. So I think with that, I'd turn it over to James and let him jump into some of the analysis considerations.
Thanks, Peter. And James, are you ready?
Yep. Hi, I'm James Begley, and I'm with the Washington Conservation Science Institute. And I'll be doing the habitat connectivity modeling after this focal species selection process occurs. And Peter did a great job touching up what the linkage mapper software is capable of doing. But I'm just going to kind of dive into a little bit more, but not try to get too deep in the weeds because it can get a little bit techy. So the linkage mapper software was from what Peter said earlier, was essentially developed by members of the working group to do this sort of modeling in the beginning for the statewide analysis, and then to led into the Columbia Basin project. And the linkage mapper software is essentially a set of GIS tools that allows you to run resistance surface-based modeling using discrete corridors, which essentially means mapping corridors between different areas of core habitats or habitat concentration areas. And it generally starts out with a resistance surface. Essentially, first you got to choose your focal species, and then there's different ways you can go about developing a resistance surface, depending on what type of habitat models might be available for the particular species. You could use resource selection functions and potentially the inverse of that, which there's some issues with, or you can expert-based spreadsheet approach like what we see here on the screen. And I'm just going to walk through this a little bit just to kind of give you an idea on you can see on the top, especially in the top right, the different focal species for this particular exercise. And then on the left, on the first column, is a set of GIS layers that represents different habitat features, topography features, or potential threats or risks associated to the species. And you assign different resistance values per cell. It's a raster-based type analysis, and cell sizes, I think, for the statewide analysis are 90 meters. We're probably going to be using about a 30 or 25 meter cell size for this. But essentially, what the resistance surface does is it assigns a resistance value per cell based upon all these different habitat and risk factors. And it essentially tells the computer how difficult or easy it is for an animal to move across that cell. So if it's really good habitat for that species, it's going to have a low resistance. And if it's really poor habitat and near roads or urban areas, it's probably going to have a high resistance. And you can move to the next slide there. So what we're looking at here is a resistance surface from I believe the Columbia Basin project. I believe, yeah. And this is for the sharp-tailed grouse, and you can see there's some habitat concentration areas that are put on there, but this particular map is showing essentially how difficult it is for an animal to move across the landscape. So if you look at the resistance values there, the landscape resistance, 1 has a low resistance value, then it goes up to 2,000, and that's essentially representing meters. So the resistance value gets to 2,000, it's essentially saying that it essentially takes the animal 2,000 meters of energy to go across that particular cell. And this leads into putting into the linker mapper software and getting cost-weighted distances from those habitat concentration areas. And the cost-weighted distance is essentially the summation of those resistance values from one habitat concentration area to the next. So it's a really good indicator of how permeable the landscape is for that particular species. And this is the surface that you run to get least cost corridors, least cost paths, and the pinch point mappers. And you can show the next slide. So this would be the result of a least cost corridor analysis based upon that cost weighted distance surface. And this is essentially showing the corridors that would have the least amount of energy expended by an animal from one habitat concentration area to the next. And these would be the areas that you'd want to really concentrate your conservation efforts. With some caveats, there's some interpretation with all this stuff that's got to be considered. It's not that an area outside of those corridors, an animal won't be there, but it's a high cost, and it's probably not. If you were trying to focus on conservation efforts, you probably wouldn't want to be focusing on areas outside of those corridors, because it's probably not the best place to invest those efforts. So that's, I think, pretty much it on my end. I think Peter did a pretty good job introducing linkage mapper also, and we should probably start moving on to the focal species selection process.
All right. Thanks, James. That's a pretty good preview of where we're going, where we're trying to end up. I'm going to talk a little bit about focal species selection. So you're staring at a map that shows the overlap of 5 different focal species networks with the different colors representing different levels of overlap. So bright red areas with more species, the maximum number overlapping, and then kind of purple for one less, and so on, showing how you can kind of judge where there's a network that provides good conditions for the maximum number of focal species while still covering the landscape of interest to the best degree possible. So the important thing with focal species and why we use focal species is because we need to answer the question of connectivity for what? What are we trying to provide connectivity for? And for us, it's often that we want to provide connectivity for the broadest possible range of native species in our geographic area of interest. So we need to choose focal species with that in mind. And what we've found is that we can establish some criteria, do some expert opinion sort of ranking or decision-making about those species and their association with the habitat conditions that are of greatest interest in our project area, as well as sort of their sensitivity to different kinds of barriers on the landscape. So we want to use expert opinion to judge whether the movement choices by each species are affected by encounters with things like lands that have been cleared, areas of human development, roads, people or domestic animals. Jeff Azarad's going to go into these criteria in a little bit more detail in a bit, but I thought it wouldn't hurt to hear them a couple times. In selecting focal species, we're thinking kind of in terms of umbrella species, species whose needs, if taken care of, will also take care of many other species. We want to consider connectivity for those species in terms of movements associated with their normal home ranges. We want to consider long-range dispersal of individuals of the species. And in some cases, it can even be instructive to consider those lower mobility species who might be considered corridor dwellers, where connectivity is achieved over multiple generations by providing connectivity in sort of broad enough swaths of land to incorporate a variety of habitat conditions that meets all the needs of an animal that is living its life in the connecting swaths of habitat that we often call linkages. So to achieve that for these focal species, we have to represent the landscape in a way that expresses what our expert opinions tell us are the likelihood of the animal moving through the area. And there's obviously going to be areas they move through easily, and then those where it's more difficult. And it's these resistance values that are based on all the different parameters and are then assigned to these pixels, these individual 30 by 30 meter cells that establish this resistance surface. And you can think of barriers on the landscape as anything that causes a behavioral avoidance, or it could be a mortality sink where the animal doesn't avoid it behaviorally but ends up dying in the process of moving into or through the area. So let's take a look at my next image here.
Hey, Kelly, can I just interrupt for 1 second? I got a chat on the webinar that some people are having some trouble with the audio. Is that a problem? And hopefully you can hear me.
Yeah, I can hear you, Tom, just fine. And unfortunately, other than speaking more loudly into my phone, I'm not sure what I can do.
I'm hearing you guys fine, both of you. I'm wondering if the people complaining about audio are trying to interject and you have them muted?
I don't know. We don't have, you know, aren't we, we're all connected via the phone, not via computer, not via the internet, right?
Yeah,
well, you heard me, so apparently you don't, by accident, have everybody muted.
Guess not, yeah. Okay, I wish I could do something so that everybody could hear well, but I can't think of anything I can do. So
I can hear you fine. I can hear you fine. I guess I'll just ask folks to say yes if they can hear Kelly fine.
Yep, sounds good here.
Yep.
Yep, I can hear him.
Yeah. All right.
Yep, good.
Yep.
All right, that sounds like a bunch of people. Well, I'm about to wrap up, so Jeff will be the next test. This last image that I have is really just an attempt at showing how using focal species and this linkage modeling process, we can end up with products that can be used in a variety of ways, including combining networks for multiple species. In this case, we combined species in what we ended up calling a generalist species network. It was a grouping of species that we felt were more habitat generalists, and applying it to a problem on US 2 between the junction, between the junction with the highway coming down off Blewett Pass and Wenatchee, where lots of mule deer are hit every year, and looking at how the connectivity products suggested areas where good conditions approach the interstate, the highway, on both sides, north and south, giving us opportunities to look at how we can not only work on habitat improvements, but also crossing structures and amenities on the highway itself to help animals get safely past the highway and present less of a hazard to drivers on that highway. So with that, I think I'll turn it over to Jeff to get into a little bit more of the details of what we're looking for in terms of help with focal species selection.
All right. Hey, thanks, Kelly. Can everybody hear me?
Yes.
Good.
All right, I'm hearing
Good.
yes.
Yes.
Good. So I'm going to just switch over to my screen. So let me see here. Share. And I'll be on my kids for a second. So, okay. All right. So, so as Kelly mentioned, we're needing some expert feedback to sort of help in the selection of focal species and try to get some information specific to the focal species to help with the modeling. So I'm going to kind of run through a sort of a decision support table that we put together where we're going to be trying to glean some of that information. We designed it to help us gather feedback from essentially species specialists and experts such as many of you on this call today. And in this table, we're hoping many of you will be able to provide us with some critical information, and that information will later use to inform the selection of focal species, and the actual species selection discussion will actually take place in person sometime in June, and we're hoping that that many of you might be interested in attending that as well, and we'll send out a doodle poll for those of you that would like to attend to try to find a date that's convenient to schedule that meeting. So what I want to do now is just kind of orient you to the sort of the nuts and bolts of trying to gather that information, and the table basically that we're using to populate with information that will help us with assessing each species and determining which ones might be suitable for us as a focal species. So as I'm doing this, I want to encourage you to stop me at any time if you have any questions, particularly if anything I describe is either unclear or ambiguous. So pop in any time if you do have questions. I'll try to go as fast as I can too, because I think the end of this we have some time set aside for questions as well. But feel free to stop me as well. So you're looking at here is a table we'll be emailing you later, probably later today, and we designed it to get your feedback on species that occur in the planning area for this connectivity analysis, which you saw on that map. And in this first tab is just some general guidelines to orient you to the table. I'm not going to go through each of these. As I kind of go through the other tabs, I'll describe sort of what we're looking for and how to sort of how to populate the table and what we're sort of looking for. But if you forget after the call and you need to sort of reorient yourself, this first Read Me tab is a good place to go. After that, there's a whole bunch of other tabs, and the first couple are really just kind of some informational tabs that we put together with some information that we felt was important in terms of helping and make some decisions in terms of populating the subsequent worksheets. And so the first one is basically just looking at ecosystems. So on this side here, we have ecological systems, and this is all from our State Wildlife Action Plan, I'm saying WDFW State Wildlife Action Plan. So these are all the ecological systems that were mapped in the State Wildlife Action Plan in descending order from the most common to the most rare. Now, the ones that are common, we're pretty sure are there. When you get down to these ones at the bottom, maybe not as sure. This is a very coarse-grained way of looking at the planning area. But these are the ones at the top are ones that are certainly pretty common throughout the planning area. On the columns, we have basically species, and these are the species of greatest conservation need from our SWAP. And what you're seeing here is basically from the SWAP, we tried to do an association between species and ecosystems. And so you can see in dark green, these are species that are closely associated with a particular ecosystem, and closely associated is defined up here. And these are species that are associated, less associated, but still with the ecosystem. And again, the definition of that is up here. So again, this is just informative and might be useful if you decide to work through this and provide some information. Another one is, another informative piece that we included was this also from the State Wildlife Action Plan. And essentially what we did was we took the most common ecological systems, kind of the top 10 up here, maybe 7, I'm not sure exactly the number, and we showed essentially where we believe these systems to occur. Again, this is very coarse, but it does give a sense of where particular systems occur on the landscape. You can't really zoom in to a point, to a cell, and say, oh, well, that's there. Not necessarily. It's more for just looking at the landscape at a broader scale. Again, kind of informational might be helpful as you're working through this. Let's see here. So let's see here. So the next several tabs, and I'll go to this one here, okay, are the actual worksheets where we're looking from information from all of you. And each worksheet includes species that we grouped by major cover types. So for instance, this first tab lists all the species in the planning area that are at least commonly thought of as either riparian or wetland or open water associated species. And we just have similar groupings. We tried to group these as best we could for conifer forests, mixed conifer hardwood, sort of major ecosystem types, grasslands and prairies, nearshore environments, high elevation, and then sort of this generalist tab. I'll go back to this one here. And within each of these worksheets, I mean, is a list of species. And to develop these lists, we first kind of cast a very wide net. In doing this, we imported most of the terrestrial mammals, herps, as well as resident birds known to occur in western Washington, as well as some inverts where we had some data. And then we subsequently narrowed down that list by examining each species against a set of criteria to determine their suitability as potential focal species. So the species that made the cut are highlighted in green, while species that didn't make the cut are found below in gold in each tab. So in this second cut, the species shown in light green kind of rose to the top. And so among the reasons a species might not have made the cut included such factors as maybe their movement scale was too limited for this analysis, or their range was too limited. Maybe they were just found in a very small portion of the planning area, or they lacked sufficient data to model them. And so actually, if you look in column Z, not for these green ones, but for the ones below, we do actually provide the rationale for each of those in case anybody does disagree and says, you know, and that's one of the parts of this exercise is if there is some disagreement, then providing the rationale for why one of these species might be bumped up to sort of the candidate. We definitely want to know that. So this kind of leaves us with those species in green, which are the candidate species, candidate focal species. And in general, these are the species where we're needing your expert input. And that said, I think it might be useful to run through the table using an example species to show the type of information we're looking for from all of you. And the one I work on a lot myself is Columbian white-tailed deer. I'm the species lead for the diversity division at WDSW. So I felt like this is one that might be a good one to run through. So this is in the open water riparian wetlands grouping, and a couple other species kind of came to the top, including beaver and mink. But before I kind of run through for Columbian white-tailed deer, I want to kind of say a few things. First of all, there's a lot of species in each of these lists, and we're not asking for everybody to go through every single species and provide their feedback on those. Mostly we're just looking for the ones you feel you're an expert or have some information to share that you feel will be informative for species selection, and also providing additional information if that species is selected to help with the modeling effort. The other thing I want to mention is, and I kind of mentioned that before, just because the species is in green, or just because the species is down here in this bottom here in the gold, doesn't mean that if you disagree with the rationale, that it shouldn't be bumped up. So if you do disagree with the rationale, there's a sort of a section. Please fill out and I'll go through how to fill it out. Fill it out, and then provide maybe at the end there's a little note section around, the reasoning why you don't think that this species should be excluded as a possibility. So with that, I'll kind of just go through quickly for Columbian white-tailed deer. And so one thing you'll notice is if you hover over a lot of the cells, they have either information or they have examples to provide context and instructions. So for instance, if you hover over the species name for most of the species, it provides the ecological systems. For Columbian white-tailed deer, it's a swap species, so it provides the ecological systems that species is associated with. And you can see there are two systems that have 2 stars afterwards, and those are the systems that they're closely, very associated with, and part of the reason why they're considered sort of an open water. They're in that open water riparian wetland grouping. So that's some of the information. And then up here, there's a lot of context as well, like for instance, and I'll get to this later, but so if this was a species that you felt like, okay, I got some information I'd like to share for this particular species, you first just put your name in this here, and I'll send out the spreadsheet to everyone so we know who's made the review for this one. And then starts out with a bunch of stuff in bold, or not bold heading, and this is more just informational again. The columns where we're looking for information are the ones that are in bold, but this just gives basically status, NatureServe global status, IUCN, WDFW-PHS, and whatnot. So just some information. Where we're looking for your expert opinion is here on from this row, from this column on. And in the beginning, there's a series of yes/no questions, and essentially it's just trying to get a sense of the threats to those particular species. And it's not getting a sense of the degree to which each threat is a threat. It's more just seeing if these are threats or not. And so these are just essentially yes/no questions. And if you click here, you can see that there's a drop down. And if you don't know, there's a place to just say I don't know. But for Columbian white-tailed deer, I determined that they're certainly threatened by clearing of land, certainly threatened by development, especially development of certain intensities, and we get to that over here to provide that information. Roads and traffic, that's a big issue. People, domestic animals, still an issue, maybe not quite as much. And so that's kind of the first thing we're looking for, is just that, and this will help us identify if this is a species. If there are no threats to the species, then maybe this is not one we would select. It's not necessarily the only factor, but it may be a factor. And then we get into this other set of information we're looking for that's more on a scale, and it's trying to get a sense of, is this species susceptible or sensitive to things such as climate change or barriers, and also what's the general mobility of these species. And so for instance, so you click on here and you can see, kind of highlight this tab, and there's these 5 categories that the SWAP put together to kind of rank species in terms of climate sensitivity, and so I used those, and so this is kind of a guide, and at least for Columbian white-tailed deer, I gave it a 7, and it's likely to experience significant influence from factors associated with climatic changes, potential implications to long-term persistence. Well, this is a species that's in the floodplain, and currently in the floodplain. Maybe it wasn't in the floodplain 100 years ago. Actually, it wasn't relegated to the floodplain, but now it is. And much of its habitat is susceptible to sea level rise. A lot of the habitat could be gone because it's in the tidally influenced part of the floodplain. And so that's the reason I gave it a 7. I didn't give it a 9 or 10 because I didn't think that was definitively that is definitely going to go extinct. But I do think that's a big factor. And so that's that's why I gave that one a 7. For mobility, I was just kind of looking at these scales here. So again, we give some information about what each rank means. So like a 1 to 2 means a species that's kind of mobile, like a land snail, or a sedentary salamander, like a torrent salamander that doesn't move very much, or very high, like a wolverine or a wolf. I don't think it's either of those, but I certainly think it's probably somewhere in the middle, where I put black-tailed deer or coyote as examples. So this might inform the analysis. If we put down that the species has a very low mobility or sedentary, probably not the best species to choose. So that would go into selection. And then susceptibility to barriers. And then there's some guidelines there up on there, and I gave this one a 7, thinking that there are certainly some barriers, and it's quite susceptible to barriers. And for the sensitivity barriers, we actually we need a little more information, or we try to get a little more information to flesh that one out. And so in here, it's really trying to get at as much information as we can get about what's the susceptibility to barriers. So for instance, I said moderate intensity development, and I even went down to the level of saying, if you got an area with 1 home per 5 acres, it's probably not habitat that they're going to move through, but they can move through habitat that has homes at maybe a higher density. So I tried to give as fine-grained information here as I could in sort of a short phrase, and then we can always go and ask questions to try to dig a little further there. Moving along, we want to know about, is this a species that requires both maybe aquatic and terrestrial linkage? And for Columbian white-tailed deer, that's a big yes, because most of them are on islands. And if for genetic interchange, they need to swim. They need to try to make the crossing sometimes. Not always, but sometimes. A little information is helpful in terms of maybe trying to group this species, and maybe the species is a species that can represent other species that are associated with a particular seral stage. So providing information about, is it early, mid, late, mature forest is also information we're looking for. Association with other structural habitat components, particularly if those components can be mapped for the modeling effort. So for instance, say it's pocket gopher. I couldn't really quite think of anything for Columbian white-tailed deer, and these are abiotic. So for pocket gopher, for instance, maybe it's prairie soils. That certainly can be mapped. For peregrine falcons, it could be cliffs. So that's some other information that's helpful to us in terms of species selection, but also in terms of what data layers we might need. Socioeconomic considerations, if there's anything. So is the species a pest? Is it culturally important? Is it economically important? This one certainly would be of recreational importance if it was recovered to harvestable populations. And then data availability. Here's some questions kind of up there to think about if you're looking through this one. Is there enough data to support modeling? Do we know enough about the conditions that promote or deter movement? If there isn't data, there's actually the last question is, are there any habitat suitability models for this species? So these are kind of some data gathering. This helps us to gather the data, and if you know of data that maybe we don't know about, this is where we would hopefully find some of that. And then, since we can't model every single species, we also try to see what species might be good representatives for a broader group of species. So if there is any information you can provide here, that's helpful. And then the last 2 columns are really just for kind of that informational stuff that I mentioned before, which is the last one here provides the information for why we decided to put these in sort of the reject column. Again, they can be brought back up, and if you do feel that our decision was made in error, this is where you would provide the data that I just mentioned before, and then provide maybe a little rationale over here for why you disagree with our assessment. So yeah, so that's kind of it. I apologize. I just looked at my clock. I think I just ran over a little, but I'll say that we're looking for your feedback, and we've got about a 2-week turnaround time that we're hoping to get that back. And unless somebody is planning to go through this for every single species on the list, it shouldn't take more than an hour, maybe less, give or take, do in the next couple of weeks. Then after that, we're going to be digesting all the information, synthesizing it, preparing for the in-person workshop. And at that point, we'll take all that information and the experts who we have there to help identify which species would be suitable or as a potential focal species. We're looking at maybe identifying about 3 to 5, maybe 3 to 6. Kelly, do you have anything else on timelines out from there? And then I guess quickly open it up to questions.
I mean, the only other thing I would add is that once we've got focal species selected, we're going to be looking for the people who know the most about those focal species to help us with the development of these resistance values that allow us to create a resistant surface, and also the habitat concentration areas, and really identifying the most sort of core areas of good habitat for our focal species, and trying to get that all squared away probably by the end of summer, maybe around August 31, so that all of this can be turned over to James Begley so he can start the linkage mapping.
Great. All right. Well, I think I'll give it back to Tom.
Yeah, no.
And if there are any questions, and I guess we'll take questions here.
Yeah, no. Yeah, let's take some questions if anybody has any. Feel free to either type it in the chat box or do it on the phone.
This is Noelle. Can you hear me?
Yeah.
Yeah.
Yep.
So I just want to make sure I understand the species that you have all on this already are based on the priority habitat species list and threatened and endangered species in Washington, or in our ecoregion, correct?
Not necessarily. No, it's more it's a broader group of species that are on this in this spreadsheet. It's species that have we're really looking beyond just PHS and T&E species, although certainly some of those might end up becoming a focal species.
I guess if I had to say it in a very succinct way, I'd say these are species whose mobility is suitable for the size of our project area, that they represent the habitats that we think are the key habitats, the most important habitats in this project area, and probably number 3 would be that they move across the landscape and respond to barriers in a way that is reflective of what many species do.
Okay. And then at this point, are you open to, and I'm sorry if you said this already, if there's a species that isn't in here, whether it's in the green or the tan box, are you open to hearing about different species at this point, or do you just want to work with the ones you have right here?
We're open.
I forgot to mention that. No, of course. If there are species that we missed altogether, by all means, add those.
Okay. Okay, cool. All right, thanks. That's my question.
Hmm? Any other questions?
I guess people have to get back to work.
Yeah.
Well, hopefully you'll all be working on this now for a little while. So Jeff, how can people get the spreadsheet?
So the way we're going to do it, we were going to do it on Google Docs as a shared spreadsheet, but we've had some technical difficulties with that. So the way I'm going to do is I have a few more things I need to do to get this all ready, and I should be able to do that today. So what I'm going to do is I'm going to email a copy of it out to all the folks who participated in this webinar, and I'll give and like I said, we'll be looking for feedback by the 15th of next month, or I guess May 1st. I'm not sure. I guess this month. So I will email that out to everybody.
We should probably include the broader group of people that maybe couldn't make it that wanted to. Yep. So there's a broader list, and we could include the link to the recorded webinar along with that. Yep. So if they want to.
Yeah.
Okay.
Great, Tom.
Yeah, definitely.
Good. Well, hopefully that's clear, and we'll probably end up bugging people at some point, friendly, polite bugging to get information too at some point. So. But thanks, everybody, for tuning in. And if there's any other questions, feel free to ask us. Kelly and Jeff are great with the spreadsheet. And if you want broader questions about the broader project, ask me. Anything else that anybody presented wants to say?
Nope.
Nope.
Good job, you guys.
Thank you for all of your work. Really appreciate it.
You're welcome.
Thank you.
Well, thank you.
Thanks, everybody.
Thanks for calling in.
Thank you.
Thanks.
Bye-bye.
Bye.
Bye.
Bye.